Hello students, welcome to Siri PathaShale. Actually ನಾನಿವತ್ತು ಲೈವ್ ಸೆಷನ್ ಶುರು ಮಾಡಬೇಕಾಗಿತ್ತು, ಆದರೆ ಡ್ಯೂ ಟು ಸಮ್ ಟೆಕ್ನಿಕಲ್ ಇಶ್ಯೂಸ್ ನಂಗೆ ಇವತ್ತೇ ಲೈವ್ ಕ್ಲಾಸಸ್ ಮಾಡೋಕ್ಕಾಗ್ತಾ ಇಲ್ಲ. ಆದರೆ ನೀವು ಡಿಸಪಾಯಿಂಟ್ ಆಗಬಾರ್ದು ಅನ್ನೋ ಕಾರಣದಿಂದ ನಾನಿವತ್ತು ನಿಮಗೆ ರೆಕಾರ್ಡೆಡ್ ವಿಡಿಯೋನೇ ಅಪ್ಲೋಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. Let us start with the chapter pair of linear equations in two variables or simultaneous equations. ಯಾಕೆ ನಾನು ಈ ಚಾಪ್ಟರಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದೆ ಅಂದರೆ as you all know, in most of the schools already you have finished with the chapters, first two chapters. ನಾನೀಗ ಅದನ್ನೇ ಮತ್ತೆ ರಿಪೀಟ್ ಮಾಡ್ತಾ ಇದ್ರೆ actually you cannot learn anything. Already you have learned something about that. I'll cover those portions at the end during revision time. So ಈಗ ನಾನು ಥರ್ಡ್ ಚಾಪ್ಟರ್ ಇದು pair of linear equations in two variables. CBSE ನಲ್ಲಿ ಸ್ಟೇಟ್ ಬೋರ್ಡ್ ಅಂದರೆ SSLC ಬೋರ್ಡ್ ಎರಡರಲ್ಲೂ ಕೂಡ ಇದು ಥರ್ಡ್ ಚಾಪ್ಟರ್. So I start with this chapter, simultaneous equations or pair of linear equations in two variables. Okay. First of all, let us learn what is a linear equation in two variables. Yes, already in 9th standard you have learned that. Yes. Let me explain with an example. Let us take the example of a situation. For example, now you are going to a shop, okay, fruit shop, and you want to buy 2 bananas and 4 oranges. Okay, 2 bananas and 4 oranges. Total amount you have paid is 50 rupees. Okay, so you have paid 50 rupees, that is the total amount for 2 bananas and 4 oranges. Now you want to know how much you have paid for each of the fruit. Andre 1 banana keshtu, 1 orange keshtu you want to know. Okay. In this case, we are using the knowledge of linear equations in two variables. How? Let me explain now. Let us take cost of 1 banana. Cost of 1 banana as rupees X. Okay, cost of 1 banana rupees X and cost of 1 orange as rupees Y. Cost of 1 banana is rupees X and cost of 1 orange as rupees Y. Let us assume that. So what are these? You all know in algebra we call these X and Y as variables. Okay, we have two variables. Now how to find the cost? We are using this equation, that is 2 bananas. So for 1 banana how much? It is X rupee. So 2x, 2 into x is 2x plus for 1 orange rupees Y. So for 4 oranges how much it is? 4 into y, that is 4y is equal to how much? 50. Okay, this is the equation we got. So 2x plus 4y is equal to 50 is a linear equation in two variables. Okay, here x and y are the variables. I can write the same equation in another form, that as 2x plus 4y. If I transpose 50 to LHS, I will get minus 50 is equal to 0. This is standard form of linear equation in one variable, in two variables. So 2x plus 4y minus 50 is equal to 0. Let me take one more example. Yes, let us take m plus n is equal to 0. Yes, this is also a linear equation in two variables. I'll take one more. It is 3a minus 5b is equal to 25. 3a minus 5b is equal to 25. This is also a linear equation in two variables. In all these equations we have two variables here, x and y, here m and n, here A and B. These are the variables. So I can write these also in standard form. How can I write? M plus N minus 0, that is nothing here. So M plus N is equal to 0. Or here I can write 3A minus 5B minus 25 is equal to 0. This is standard form of the writing the equation. So what is a linear equation in two variable and what is its general form? Okay, are there any conditions? Yes, we have condition here. So if I write the general form of the linear equation in two variables as ax plus by plus c is equal to 0. Here the condition is a and b should not be equal to 0, where condition is a and b both should not be equal to 0. Now my question, what happens if a is equal to 0? What happens? Yes, for example here, what is the value of a? A is 2. If I get a is equal to 0, here 0 into x, what do I get here? I get 0x is 0 only. So 4y minus 550 is equal to 0. Then how many variables do we have now? A single variable. So it becomes a linear equation in one variable. Here, if n is 0, n is here, b is equal to what? N. Then m is equal to 0, we get only single variable. So it would be a linear equation in one variable. Here also, if any of these are both, if they are equal to 0, what happens here? We get the condition that we won't get a linear equation in two variables. So, linear equation in two variables ಸಿಗಬೇಕಿದ್ರೆ a ಮತ್ತು b should not be equal to 0. 0 ಆದರೆ we will get a linear equation in one variable. So, this is the condition to be satisfied. Okay, so how do you get, what is the general form? General form of linear equation in two variables, it is ax plus by plus c is equal to 0, where a, b and c can be any real numbers. Already you have learnt about real numbers. Okay, a, b, c, that is general form is ax plus by plus c is equal to 0, where a, b and c are any real numbers. Real numbers means they can be rational or irrational numbers. Rational numbers or irrational numbers. And one more condition is a and b should not be equal to 0. Same condition can be written in another way also, that is a square plus b square should not be equal to 0. Same. Okay, obviously yes, if a and b are not equal to 0, yes, a square plus b square also should not be equal to 0. This is the condition. This is general form of a linear equation. Now let us come to the point. Simultaneous equations are pair of linear equations in two variables. Yes. Now first let us know why we need a pair of solution. To get a unique solution, we need a pair of equation. For example, if I take the previous example, that is 2x plus 4y is equal to 50, I can have any number of solution. Let us assume if x is equal to 0, then what do we get? 4y is equal to 50, y is equal to 50 by 4. 50 by 4. Okay, what do we get here? 12.5. Okay, or if I take x is equal to 1, what do I get here? The 2x raised to into 1 plus 4y is equal to 50. So 4y is equal to 50 minus 2, it is equal to 48. So y is equal to, what do we get here? 12 rupees. Okay, this y value 12 rupees. So x is equal to 1 rupee. Okay, y value 12 rupees. 48 by 4, it is 12. 12 rupees. Okay, so we can have different solutions for this now. Now let us discuss about simultaneous equations. In the simultaneous equations, how can we get the solutions and what are the uses of that? Okay, everything we know here in this chapter. Okay, so let us discuss about simultaneous equations or pair of linear equations in two variables. Now let me explain this with an example. I am taking the same example because here, for example, you want to buy two chocolates. Okay, chocolates, two chocolates, and you want to buy three biscuit packets. Okay, two chocolates and biscuit, or three biscuit packets. And then you are going to pay. You are going to pay 50 rupees together. Okay, 50 rupees together. So 2 chocolates plus 3 biscuit packs together you are going to pay 50 rupees. Okay, now yes, let us take cost of 1 chocolate X rupee and cost of 1 biscuit packet as Y rupee. So it is equal to 2x plus 3y is equal to 50. Okay, now there is one more condition, that is cost of one biscuit pack is 2 times of cost of one chocolate. Okay, twice. So cost of one biscuit pack. Cost of, another condition here, cost of one biscuit pack is twice of cost of one chocolate. Cost of one chocolate. So using this condition, we need to solve this. Okay, so cost of one biscuit packet, how much we have taken actually? Y. Y is equal to what? 2 times. Cost of one chocolate is X rupee. So 2 times of X. This is the condition. Using this condition, we need to solve this. How many equations do we have now? Here, this is one equation. This is second equation. So we have 2 equations here. Okay, so when we have 2 equations, then we can solve the answer. Because that value, we get a pair of solution here, numbers. Okay, pair of numbers, one value for X, one value for Y. Then also that pair of value numbers, okay, that is what solution for both the equations. Okay, solution for both the equations. We get a unique solution in this case. Okay, when we have single equation, we may have any number of equation, any number of solutions for that. But here we get a unique solution, or we may not get a solution at all, or sometimes we may get infinite number of solutions. How? Why? For all these questions we learn in this chapter. We get answers in this chapter. Okay. So here these 2 equations together, I call them simultaneous equations or pair of linear equations in 2 variables. Now how is the standard form? How can we write? Okay. If I take A1, A2, A1, B1 and C1 as the constants or real numbers in the first equation, and A2, B2 and C2 are the constants or the real numbers in the second equation, I will get the general form of first equation as A1x plus B1y plus C1 is equal to 0, and here A2x plus B2y plus C2 is equal to 0. Okay, so here this pair of equations are called simultaneous equations in standard form, or pair of linear equations in 2 variables. In both the cases we have x, y, the variables, and here a1, b1, c1 A2, B2, C2, all these are real numbers. And here what is the condition? A1, here A1, B1 and this one, they should not be equal to 0. That means here these number constants are real numbers A1, B1 and A2, B2. They should not be equal to 0. That is the condition should be satisfied. So this is called pair of linear equations in two variables. Okay. Now let us know how to find solutions for this. Okay, yes, in the previous example for single equation I told yes by trial and error method, by assuming different numbers we may get solution. But here when we have two simultaneous equations like this, we can find the solutions easily by different methods. We have 4 methods here. Now let me explain with an example. I'll give you an example. You may enjoy this example. Now let us consider we have a circle connected with 4 roads. Circle connected with 4 roads. Now a tiny cat, okay, 2 tiny cats, they are coming to tiny cats. Are coming in opposite direction. 2 tiny cats are friends coming from opposite direction. So yes, you can say at how many points can we get here where they meet? When both of them, so this is coming in this direction. Okay, this tiny cat is coming in this direction. At some point in between, they meet. Let us assume both the cats meet here at this point. Or suppose the cats are coming like this. Okay, they also meet at a point here. Somewhere they meet here. Somewhere here, anywhere they meet. Or they may here coming like this. Okay, facing each other. They meet somewhere here. Okay, somewhere here or somewhere here. At one point, at a single point, they could meet. Okay, so where we get a single solution or a unique solution for this. Now, let us assume the same 2 cats now coming on parallel roads. Okay, another parallel road is here, and here the cat is coming. Okay, 2 cats are moving. Let us assume they are throughout their journey. Both the cats are moving in a parallel roads. Okay, moving in parallel roads. Okay, now do they meet anywhere? No, they do not. They never meet. Because parallel lines never meet. They never. Even if you extend the parallel lines for any length to infinite length, they never meet. Here also, if they keep on moving like this, even if they move far to infinite length, they travel infinite. They may have an infinite distance. They have a journey of infinite distance, but they never meet. They do not meet anywhere here. Okay, next. So this is second case. So first case, at some point definitely they meet. So we can have a unique solution. Unique solution. That point where they meet is nothing but it's a unique solution. Second case, when they move on parallel lines, or they may suppose here they are moving like this on parallel lines, they never meet. Okay, so never meet means for second case here, they never meet means no solution at all. No solution at all. Next, third case. Let us assume here they are coming on the same path, road. Okay, both are coming, and yes, many cats join in between. Okay, many cats join. Okay, then they keep on adding like this, but they are moving to infinite distance. Okay, so they keep on adding. Then what do you think of the solution now? At some point, if they move till infinity, at that point we get these many cats. Okay, many cats, infinite number of cats. Okay, so everywhere they are meeting you. Okay, one point again here, again here, again here, till the end. Okay, when they reach the end of the road, there may be infinite number of solutions or infinite number of points where they can meet. Okay, so this is third case, that is how many? Infinite number of solutions. Infinite number of solutions. So, simultaneous equations or a pair of linear equations may have either unique solution or no solution or infinite number of solutions. Now, in this chapter, we are going to learn, yes, how do we get the solutions and which are the methods of getting solutions, and yes, what are the uses, and some daily life examples we shall discuss in this chapter. Okay, so this is today's introduction class. Tomorrow I will continue with the problems. So ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಅವ್ರನ್ನೂ ಕರ್ಕೊಂಬನ್ನಿ, ಜಾಸ್ತಿ ಜನ ಜಾಯ್ನ್ ಆಗಿ ಎಲ್ಲ ಕೂತ್ಕೊಂಡು ಕಂಬೈನ್ಡ್ ಸ್ಟಡಿ ಕೂಡ ಮಾಡ್ಬೋದು.